Okay, guys, we are, this is chapter 2. 2.3 is polynomial functions and rational functions. Okay, so polynomial function is not a linear function. We were just, well, it is. There are linear functions that are a subset of the polynomial functions. Linear functions, the exponent is 1. Okay, it's x to the first, right? So, and then the graph of that, of course, is a straight line. Polynomial functions, don't be overwhelmed by this, okay? We'll talk about it, but it's of degree n, all right? For example, a linear function is degree 1 because 1 is the biggest exponent. A quadratic function would be degree 2. Whatever the biggest exponent is, that's the degree of the function. And we have numbers in front of x that are called coefficients, okay? We have a number at the end that does not have an x, is not a coefficient of x. That's called the constant. The leading coefficient is the number in front of the exponent with the biggest power. Okay, so for example, we might have f of x equals 3x to the fourth minus 2x squared plus x minus 7. Okay, this would be a fourth degree because 4 is the biggest exponent. The leading coefficient would be 3. The constant term would be negative 7. The coefficient in front of the x squared term is a negative 2. The coefficient in front of the x to the first term is a positive 1. There is no the coefficient in front of x cubed. We want each degree less than 4 represented. If that's true, then really I would say the coefficient in front of the x cubed term is a 0. Okay, so just some terminology about polynomial functions and what we mean when we talk about them. Their graphs, hey, you're welcome to use your graphing calculator to graph these. I'm just going to do them by hand quickly. We know what a line looks like. We know what x to the first, a first degree polynomial or a linear equation, what that looks like. If it's x squared plus 4, that's called quadratic. Okay, it's a polynomial function of degree 2. If I put 0 in for x, 0 squared plus 4 is 4. 1 squared plus 4 is 5. Negative 1 squared is also 1 plus 4 is 5. You're familiar with this, I know. If I plot the points, I end up getting something called a parabola. Okay, every x squared term, okay, every quadratic, every x squared, polynomial of degree 2 ends up having this parabola shape. Why? Because I'm squaring x, so every negative number turns into a positive number, okay? Instead of it going off into the negatives, we flip up here. Okay, x to the third. Let's see what g of x, I'll do that in red over here. G of x equals x to the third. Well, when x is 0, y is 0. When x is 1, I'm 1. When x is 2, 2 cubed is 8. Now this time when I put negatives in, negative 1 cubed is negative 1, negative 2 cubed is negative 8. So I get big pretty fast here. At 2, I'm already up to 8. And then the negatives, it's symmetrical. It's the same thing down here. So you end up getting this, not straight line, but kind of this curvy shape. Down to the left it goes and up to the right really fast. Okay, let's see what happens when I have to the fourth. 1/2 x to the fourth minus 7. Okay, 1/2 x to the fourth minus 7. Again, I put 0 in, I get a negative 7. Let's just put 2 in. 2 to the fourth is 16. Half of 16 is 8. 8 minus 7 is 1. Okay, if I put negative 2 in, I pretty much have the same thing, don't I? Negative 2 to the fourth is also 16. Positive 16, half 16, I still get 1 there. So 2 gives me 1, negative 2 gives me 1, but for 0, I was down at negative 7. Okay, so you also get, it's not called a parabola, okay, because it's a little flatter down here. Sorry. So a little bit flatter, but we definitely are still curving up in both ends, okay? Because again, I'm raising it to a even degree. And so all my negatives turn positive. Negative x to the 5th, since that's an odd degree, I'm going to be going in opposite directions. 0 gives me 0. 1 to the 5th is 1, but the opposite of that is negative 1. 2 to the 5th is 32, but the opposite of that is negative 32. If I put negative 1 in, negative 1 to the 5th is negative 1, but the opposite of that is positive 1. So I end up kind of going in the opposite direction as I did with the red graph, the x cubed. Okay, I'm going this way because of this negative in front. A negative in front of a polynomial kind of flips it and makes it the opposite of what it was when it was positive. A negative in front of a quadratic would make this curve down. Okay, it would still be going the same direction in at both ends, but it'd be going down instead of up. Okay, so that's where there's some general rules about a polynomial. Okay, I know you have a blank spot in your notes to graph this. I could use some XY points to graph it, but this is what it looks like. Okay, first of all, seeing that it was a 4th degree, which is even, I knew that the ends of my graph would be going either both up or both down. The ends of my graph have to be going the same direction because in the end, all my negative numbers that are raised to the 4th are the same, whether it's negative 2 to the 4th or positive 2 to the 4th. The same thing will happen here to this first term, okay? If it's negative 1 to the 4th or 1 to the 4th, same number, answer. 7 to the 4th or negative 7 to the 4th, okay? So the ends, in this case, the reason they're going down, okay, both ends are going down in the end, is because of the negative leading coefficient, okay? So the end behavior, they call it, of a polynomial, you can tell everything by the first term. The fact that it was an even degree meant the ends would be going in the same direction. The fact that its negative leading coefficient meant that same direction was down. Okay, how many times is it going to turn? You know, it depends. This turned once, twice, 3 times. At most, it's going to turn 1 less than the degree. Okay, you have to be very careful. The reason it's important to know that from the first term is because if you are using graphing technology and you just use the 10 by 10 window, it's going to look like a straight line. You're not going to realize, oh, wait a minute, there's more to this. You'd be like, wait, it's a 4th degree. It can't be just going in opposite directions. It's a negative leading coefficient. I'm going to have to make my viewing rectangle bigger. Okay? So then I see they made the y-axis go from negative 50 to 50 so you can see the whole thing. All right, so make sure you play with don't just graph something on a 10 by 10 window and assume that you see everything. Okay, polynomials could be going all over the place. Basically, if it's a degree, like in our case, it was degree 4, it's going to have at most 3 turning points. If it's degree 7, it's going to have at most 6 turning points. Might not have that many, but the most it will possibly have is 6. Okay? If it's even, like we were saying, an even degree, like 4th degree, 6th degree, 2nd degree, both ends either go up or both ends go down. And again, that depends on the leading coefficient. If it's negative, it goes down. Positive, it goes up. For a polynomial function of odd degree, like 3 or 5, like we saw, one end goes up, the other end goes down. Okay? And then, like we said, if the leading coefficient is positive, then we know that the right-hand side of our graph is going to be going up, okay, as x becomes bigger. If the leading coefficient is negative, then the graph, the right-hand side of the graph is going down. Okay? All right. Anyway, those are some properties of polynomial functions. Then, and we're familiar with those from college algebra. We'll get to graphing some more of those, etc. in your homework here, and getting used to that. Rational functions in general is a polynomial over a polynomial. However, the denominator can't be 0. So your basic rational function is y equals 1 over x. If you want to think about what that looks like, I can't put 0 in, right? I'll start with 1. 1 over 1 is 1. 2, 1 over 2 is a half. 1 over 3 is a third. 1 over 4 is a fourth. Okay, so I'm at 1, 1, 2 a half, 3 a third, 4 a fourth. If I put 1,000 in, I'm at 1 1,000ths. I realize I'm never going to get to 0. Okay, so I have to be, I can't put 0 in for x. There's never going to be a 0 something. So we end up just making a dotted line to show that, hey, x can't be 0. The denominator can't be 0. And we end up making a horizontal dotted line to show, hey, I'm actually never going to reach 0 for the y coordinate either. Okay, your basic rational functions are odd because we have these, I mean weird, not odd like an odd number. We end up getting something like this with something called asymptotes because x is never going to be 0. But the closer I get to x, like if I would put a half in for x, 1 divided by a half is 2. So a half, 2. 1 divided by a third is 3. 1 divided by a fourth is 4. 1 divided by 1/100th is 100. Like the closer I get to 0, the closer I get to the x-axis here. Okay, it's called an asymptote. All righty. So an asymptote is just what I said. It's either a vertical asymptote is where the denominator is 0 because we're not allowed to divide by 0. The horizontal asymptote is the bigger and bigger x gets, what am I getting close to? Okay, like we saw before here. I was putting 1,000 in for x. The bigger x got, the closer y got to 0. So 0 was my horizontal asymptote. Okay, so if we would graph y equals 3x plus 2 over 2x plus 4, if I wanted to know the horizontal asymptote, I would take the denominator and set it equal to 0 and see that that would give me x equals -2. What that means is I can't put -2 in for x. 2 times -2 is -4. -4 plus 4 is 0. I can't do that. So I'm going to drop a vertical asymptote down at -2. Okay? The horizontal asymptote is harder to find. It says as x, absolute value of x gets bigger and bigger. So first I usually just put some numbers in to give myself an idea. I might put 0 in for x. That gives me 1/2. I might put 1 in for x. That gives me 5/6. Okay. I'll put 2 in for x. That gives me 1. Okay, and then I put 3 in for, well, we want to get bigger and bigger. Let's put 10 in for x. When I put 10 in for x, I get 32 over 24, which is like 1 1/3. That was 10? Yeah. Okay, so I can kind of start seeing this horizontal asymptote happening, but I'm not sure where it is. My vertical, I know I'm going to hug my vertical asymptote, but I'm not sure where my horizontal asymptote is. 1 1/3, maybe I'll put, let's put 100 in. If I put 100 in, I get 302 over 2